Hello everyone and welcome back. Today we are going to explore one of the most fundamental signals in digital signal processing, the unit step sequence using MATLAB. Now by the end of this video you will know what the unit step sequence is, how it behaves and how to generate and plot it in MATLAB with ease. This signal forms the foundation for understanding many advanced DSP concepts and real-world applications. So grab your laptop, open the MATLAB, and let's transform the theory into a simple visual and practical learning experience. Let's get started. So here you can see the unit step sequence, and it is one of the most fundamental discrete time signals which is used in DSP, that is the signal digital signal processing, and it presents the concept through its definition, mathematical expression, graphical representation, then key properties and applications, making it easy to understand its importance in digital system analysis. So here you can see first the definition. The unit step sequence, it is denoted by u of n, okay, that is small u of n, as a discrete time signal that changes from what? That changes from 0 to 1. That changes from 0 to 1 at the time instant n is equal to 0. And the sequence, it has a value of 0 for all the negative values of n and value of 1 for all the values of n which is greater than or equal to 0. And this behavior represents the sudden activation or switching on of a digital signal and is commonly used to model systems that start operating at a specific instant. So here this is the mathematical expression, that is u of n is equal to 0 for n less than 0, that is for all the negative values, and for all the positive values including the 0 it is 1. That is for n greater than or equal to 0 it is 1, where n is what? It is the discrete time index. Now here this equation, it indicates here, this indicates that before the origin the sequence remains 0, and beginning at n is equal to 0 the sequence becomes 1 and continues with the same value indefinitely. And this simple mathematical definition forms the basis for many signal processing operations. So here you can see the graphical representation which displays the sequence using a stem plot, which is the standard way of representing discrete time signals. Now at n is equal to 0, the signal rises to an amplitude of 1 and remains at 1 for all the positive values of n. And this permanent transition from 0 to 1 gives the signal its name, the step sequence. And the key properties are or the important characteristics of the unit step sequence are: it is a casual signal, meaning it exists only from the present time onward and does not depend on the future values. And the value at the origin, that is u is equal to 0, will be equal to 1, which distinguishes it from many other signals. And another important relation is u of n minus u of n minus 1 is equal to delta n. That is, it shows the difference between the two consecutive unit step sequences produces the unit sample, that is the impulse sequence, which demonstrates a close relationship between the two fundamental signals. And the unit step sequence is also used to represent the signals that begin at a particular time instant. Then comes the applications, where here which explains the practical significance of the unit step sequence in the digital signal processing. It is widely used to model the switching on of the digital systems. To determine next is to determine the step response of the linear time invariant systems and perform the convolution operations to solve the difference equations and analyze the behavior of the digital filters and the communication systems. And it also plays a vital role in signal modeling and simulation of the digital systems, because many real world systems begin operating at a specific instant, which can be represented using the unit step sequence. Now here you have a note which emphasizes that the fundamental behavior of the signal emphasizes the importance of the fundamental behavior of the signal, and it states that the unit step sequence remains 0 before n is equal to 0 and changes to 1 at n is equal to 0, maintaining that value for all future time instants. And this property makes it an ideal signal for representing sudden changes or the activation of the digital systems. So here we have seen why the unit step sequence is considered as one of the basic building blocks of digital signal processing, serving as an essential tool for system analysis, signal modeling, convolution, digital filter design, and the study of the discrete time systems. Now here we can see like how to generate a unit step sequence using MATLAB, which is one of the most widely used software tools for digital signal processing, and it is organized into several sections here. That is, first is the objective, then you have theory, then you have a MATLAB code, you have output plot, then code explanation, and the key takeaways, and also the result. Okay, so here the objective, it states the aim of the experiment, which is to generate and plot the unit step sequence using MATLAB. And this practical introduces students to one of the most fundamental discrete time signals and demonstrates how MATLAB can be used to visualize the digital signals easily. Now here in theory section you can see the definition, that is the unit step sequence U of n is a discrete time signal, that is 0 for n less than 0 and 1 for n greater than or equal to 0. That is, the signal represents the sudden transition from off to on at the origin and remains on here, okay, and remains on for all the future time instants, and it is commonly used to model the systems that begin operating at particular instant and is widely applied in digital communication, signal processing, and control systems. Then comes the MATLAB code here. The CLC, clear all, and the close all prepare the MATLAB environment by clearing the command window, then removing the previously stored variables and closing all the open figure windows. Then comes the statements n is equal to minus 10 colon 10, representing the sample indices. And here you have the command u is equal to n greater than or equal to 0, which generates the unit step sequence by assigning a value of 1 to all the samples where n is greater than or equal to 0 and 0 to all the negative samples. Next you have u stem n comma u, and this function displays the sequence as a stem plot here, while the x label and the y label, and then you have the title label to show the graph appropriately, and the grid on command adds the grids lines to improve the readability, these grids. Okay, so this is the output plot which you get after executing this MATLAB code, and here the graph clearly shows that the amplitude is 0 for all negative values of n, and at n is equal to 0 the signal changes to 1 and remains at this value for all the positive time indices. And since the signal is discrete, each sample is represented by a vertical stem rather than the continuous line, and this graphical representation clearly illustrates the step behavior of the sequence. And here you have the code explanation line by line, you can see here. So it explains how the MATLAB environment is initialized, how the discrete time index is created, then how the logical condition generates a step sequence, and how the graph is plotted with proper labels and a title. So here this will help the beginners to understand the purpose and the function of each statement in the program. Now the key takeaways, these here you have the important concept of the unit step sequence. It emphasizes that u of n is equal to 0 for n less than 0 and u of n is equal to 1 for n greater than or equal to 0, and the signal represents a sudden change from 0 to 1, making it suitable for modeling systems that start operating at a specific instant. And it is also called as a casual signal, meaning its output depends only on the present and the past values, not on the future values. and the unit step sequence is extensively used in system analysis, step response, convolution, signal modeling, and solving the difference equations. And here this is the mathematical representation. So here we have seen the MATLAB program which generates and plots a unit step sequence. Okay, so next you have one more program. This is the program will execute this, okay, for this one, that is generating the unit step sequence. Then one more program is discrete time unit step function using the MATLAB here. Previous one was also discrete only, but we'll see what is the difference in both the programs. So here also the objective is to generate and plot the discrete time unit step function for a given value of n using MATLAB. The formula remains the same, but there is a change in MATLAB code here. Previously we have not entered the value of n, but here we are entering the value of n. Here you can see we have taken n from -10 to 10. Okay, here we are creating a vector from -10 to 10, but in this MATLAB code we are entering the value of n. Okay, that is it takes the input from the user for the number of samples. Here you have indefinite samples, not indefinite. The samples are ranging between -10 to +10, but here we will enter the value of n, and here it takes the input from the user for the number of samples. Okay, then you have t is equal to 0 is to 0 colon 1 colon n minus 1, which creates a time vector from 0 to n minus 1 with step size 1. Then you have y is equal to 1 comma n, which creates a row vector of length n with all the elements as 1. Okay, stem t comma y, it plots a discrete time unit step function using the stem plot. Fine. Then x label, y label, and title, it remains same. So here these are the key takeaways. The length of the signal sequence depends on the input n here. Okay, because we have to enter the value of n, and this is the stem plot for n is equal to 6. If we enter n is equal to 6, we'll get 6 samples from 0 to 5. That is 1, 2, 3, 4, 5, and 6. Okay. Now this is the program for entering the value of n. Here we'll see the difference. What is the difference between the two MATLAB programs? Already we have seen, but once again we'll brush up it. So here it compares the two MATLAB programs. Okay, and this is the program 1 and this is the program 2 here. So first program is the complete unit step sequence, and the second program is the finite length unit step sequence. Okay, so here this program, it generates a standard unit step sequence using the logical expression n greater than or equal to 0, and the time index is fixed from -10 to +10. So the graph includes both negative and positive time values, and for all values n of n less than 0, the sequence will be 0. Okay, here the sequence will be 0, and at n is equal to 0, the signal changes to 1 and remains 1 for all the positive values. And this program, it follows the exact mathematical definition of the unit step sequence used in DSP. So here the output, it clearly shows the transition from 0 to 1 at the origin, helping the students to understand the actual behavior of the signal. Then comes the program 2, which generates a finite length unit step sequence using the once function, and instead of defining the signal mathematically, the user first enters the number of samples here. So the program then creates a time vector from 0 to n minus 1 and generates a vector containing only ones. So since the negative time values are not included in this program, the graph starts directly at 0 with amplitude 1. Therefore, this program does not show the transition from 0 to 1, and it represents only a finite sequence of ones. And this is the comparison table, you can see it. Okay, so this is about the program on unit step sequence. You have both the programs. Now we'll see the execution of both the programs in MATLAB. I'll copy the program from here for first one, okay, where we need not to enter the value of n. Go to the editor window and type your program. I'll directly paste the program here. Now run. See, here you can see the value of n, it is ranging from -10 to +10, and you can see the small circles now here. These are the uh, 0 values for n less than 0. Okay, that is amplitude is 0 here. Suddenly it will change to 1 at n is equal to 0, and it will continue up to +10. So this is about the first program. Now we'll go to the second program. So the second program is here. I'll copy this and I'll paste it in the editor window, then run it. So you are getting here untitled m. Here you have to give the semicolon. Now run the program. Now enter the value of n. I will enter the value of n as 5. Okay, so I should get the sample values from, that is the amplitude should be from 0 to 5. Now see here, 0, 1, 2, 3, 4. So 5 samples I am getting. Okay, here I will change it. Once again we'll do it. Once again I'll run it. I'll enter it as 7. So I should get the sample values from 0 to 6. So 0, 1, 2, 3, 4, 5, 6. Okay, so this is about the MATLAB program of the unit step sequence. So, and that's a wrap on the unit step sequence using MATLAB. Hope this video helped you to understand the concept clearly and made MATLAB program easier to follow. If you found this tutorial useful, please don't forget to like, share and subscribe to the channel for more DSP, MATLAB, Arduino and electronics tutorials, and feel free to post your questions or the suggestions in the comment section, and I would be happy to help. Keep practicing the programs on your own because that's the best way to master MATLAB and DSP. Until the next video, keep learning, keep innovating and happy coding. Thank you.